Who would like to start with questions? Hi, Miss Bond.
Hello there.
How are you doing?
Oh, just peachy. Hope everybody's good.
They're quiet today.
Oh, they're not awake yet.
Definitely not. He's not here yet.
Oh, okay. Thank you.
I don't know. He's usually team tardy, so
Okay.
we'll. If he does, I'll make sure
Send him my way.
send him your way.
Okay, thank you.
Sure. Okay. Yeah, Lily. Sure, we can look at that. All right, so it's a graphing problem. The first thing I want to do before I start any of these kinds of graphing problems is identify my values for A, C, H, and K. And to do that, I'm going to be looking at my equation. What I want to do first is to check the coefficient on x. If that coefficient on x is not 1, I'd have to start by factoring. But here it is 1, so I'm okay. So let's see. My A is -2. My C is 1. My H is -π/4. And my K is 1. Are you happy with that? Okay. Then I'm going to write my transformation map. So that's Cx plus H, and then Ay plus K. And then I'm going to look up my key points for tangent. These are something that I would give to you for a test or whatever. So they're not something you need to memorize, and these were in the notes from yesterday. And UND is just short for undefined. That's where the asymptotes are. Okay. So what I do then is I just take my x and plug it in for the x, and then take my y and plug it in for the y, and just kind of bang through those. So let's see here. That would be -3π/4. And no matter what you do to undefined, it still stays undefined. And then that's going to be -1/2 and 3. It's -π/4 and 1, and then 0, and -1, and then +π/4 and undefined. Okay so far, Lily?
Yes, you always put that X and Y. Right?
Yes.
Okay.
Yep. So each point, you're just plugging in that point's x and y to get your new point. So let's go ahead and plot these things. So if I look, it seems like every grid line is 1/2 pi. So -3π/4 would be over here somewhere that we can't really see. I'll just kind of put the asymptote over there somewhere, though. And then we have -π/2 and 3. And then -π/4 and 1, and then 0, -1, and then π/4 is my asymptote. So again, we'll go now just so we get like, there's my graph, and now we'll just kind of extend this as we go. Does that feel okay, Lily?
Yeah.
Just following the same pattern, right? Like on the line at 3, in the middle at 1, on the line at -1, in between asymptote. Jane? So that's where the undefines are. Correct. Yep. So the undefines, just that's where the asymptote goes. So you find that spot on the X and then you draw your vertical line through it. Ben?
Can I use the restroom?
Yeah, certainly. Lily, are you happy?
Yeah.
Other follow-ups here on this one before we take the next set of question or next question? Victoria?
Did you do 17
On the, you mean the problem set?
Yeah.
I was like, I don't think one of the worksheets has 17 problems. Okay. It says identify any vertical asymptotes on the interval from 0 to 4 pi. And then it gives us the function. Okay. So I remember from my from the notes yesterday that the domain for this was everything except for c times pi over 2 plus h times n, where n is an odd integer. So these places that are not included in the domain, these are going to be our asymptotes. So for this problem, I can see that my c is 1/2 and my h is 0. So my first asymptote, plugging in 1/2 for c and 0 for h, is pi over 4. Hi, Miss Anderson.
Good morning.
Good morning for you. Oh my goodness.
Yeah, this is for your community time today,
Oh,
for when we Zoom.
I see. Sure.
Okay.
Okay. So that's my first one. And then my next one, so that's when n is 1, right? When n is 3, that's the next odd number. I'd have 3 pi over 4. When n is 5, I'd have 5 pi over 4. When n is 7, 7 pi over 4. When n is 9, I'd have 9 pi over 4. Then 11 pi over 4, and 13 pi over 4, and 15 pi over 4. And that's going to be my last one, because the next one would be 17 pi over 4. but that one is greater than 4 pi, which was the end of my interval that we were looking for asymptotes on. So that's how I know I'd be finished. You don't seem very happy. Let's talk some more then. Okay.
How did you get 1/2 and then 0?
Oh, from my equation right here,
Oh,
right? So it's in y equals tangent of 1 over c x minus h plus k.
so let's do these equations, you only have to find C.
That's all that we need in order to figure out where the asymptotes are, because the a and the k don't affect the asymptote locations. Does that feel okay?
Yes.
Yeah, no problem. Lily,
Oh, so why do you stop at 17 times?
so if I went up at 17 pi over 4, that's 4.25 pi. If I convert 17 and pi, or 17 over 4 to a fraction. And the question only wants the asymptotes between 0 and 4 pi. So 17 pi over 4 is just too big. It's beyond what the question is asking for. It's still an asymptote, but it's an asymptote that's bigger than, or outside of the range that we're looking for them on. Does that make sense?
Yeah.
And it's worth noting that you could check this if you wanted to on your calculator, making sure I'm in radian mode. But if I do 2 times tangent of 2 times pi over 4, that should give me an error because it's giving us an undefined value, right? So that's what I'm getting here is a domain error, saying that what you're asking for is undefined. And I could check each one of those values that I came up with, and it would give me the same error every time. Which, as opposed to, say, if I did pi over 3 or something, I just spits out a number. Does that feel okay?
Yes.
So again, you can check stuff like that with your calculator. Victoria? Sure. We happy to move forward, everyone else? Okay. So here it says identify the period and then graph it over that interval. So the first thing I'm going to do is identify the values for A, C, H, and K. So the way it's written, I can certainly do that right away. So A is -1, C is 1/3, H is 0, and K is 0. It asked for the period, which for tangent is the absolute value of C times pi. So my period would just be pi over 3. And then the next thing we want to do is to graph this. So I'll go ahead and write my transformation map. So Cx plus H, Ay plus K. And we'll do this on our key points, which I have memorized. You do not need to do that. The graphing questions on the test will be similar in format to the graphing question you guys saw in the homework quiz, where I gave you the key points and then a blank to give me the new transform point. So it's all those key points would be given to you. So we'll go ahead and do this. So I have -pi over 6 and undefined. And then -pi over 12, undefined, 0, 0. And we have pi over 12 and -1. Oh my goodness, this should be positive 1. Sorry about that. And then pi over 6 and undefined. Okay. And then I'm going to draw my own grid here to graph this on. And I'm going to make it real long because looking at my x's, basically I'm going up by 12ths, right? So I have like negative 2 12ths, negative 1 12th, 0 12th, 1 12th, 2 12th. So I could either put 24 tick marks on here because I'm going from 2 pi or negative 2 pi to positive 2 pi. So I'd need like 24 on each side, or I'm probably just going to go by sixths and just put 12 of them on here because it's going to get a little busy looking. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have an asymptote at negative 1/6 and positive 1/6. And then in between I have 1, 0, negative 1. So there's my piece. And then I'll just draw in the rest of this to fit the space. So I'll put these asymptotes in first. Again, I just noticed that there's basically like just some one tick mark basically in between my two asymptotes. So that's all I'm doing to draw in the rest of them, just to make sure there's one tick mark in the middle. And then just kind of going ahead and extending. Victoria, does that feel good?
Yeah.
I'm going to stop drawing this because it's a lot at this point. You get the idea from here, I would hope, right?
Yeah.
Okay. If you needed me to keep going, I guess I would keep going, but this one just has a lot of cycles to draw because the period is quite small. Okay. Anybody else? Lily.
Oh, I'm sorry.
1B. Just describing the transformation. Sure. Okay, so I would start by identifying my values for A, C, H, and K. As the problem is currently written, I can do that just from looking at it. So A is 1, C is 1/4, H is 0, K is 1. You good there? We have 6 total transformations. The order which I do them is I do the stuff for C, then I do the stuff for A, and then for H, and then for K. So the C, I do the A and the C, I do the reflections first. Since the C is positive, there's no reflection. And then since the absolute value of C is less than 1, this is a horizontal shrink by a factor of 1/4. Since the A is positive, there's no reflection. And since the absolute value of A is 1, there's no vertical stretch or shrink. Because the H is 0, there's no shift left or right. Since the K is positive, we know we're going up. And since the absolute value of K is 1, we're just going up 1 unit. Okay with that? And on the test or whatever, the format for something like this, I'd have like 1, 2, 3, 4, 5, 6 listed. And if nothing happens, you can just put a dash like we've done here. Or leave it blank or whatever. Does that feel okay? Okay. Oh, right. Should we take a few minutes and talk about the test format? And then we'll release you guys to work on your stuff. So you'll have one question where we ask you to describe that transformation in words. 2 questions where I ask you to find like the amplitude, period, midline frequency just from the equation of the function. 1 question where I ask you to write the sinusoid from the description. That'd be like worksheet 4, I think. And then 1 question where I ask you to write the sinusoid from the graph. I think that was worksheet 5. And then 3 questions that are graphing questions. Okay. Any clarifications as to the format here, Jane?
When did we ever use the unit circle?
So we used the unit circle when we came up with the initial graphs of sine and cosine to figure out the key points, but that was it.
Okay, so we won't need to use that.
Not directly, no. I see no reason why you would need to use it.
And we'll just like memorize.
The key points I would give to you.
Yeah, okay. So then we're,
So you don't need to memorize them at all.
Okay.
Again, the graphing questions where you're using those key points to graph are going to be like the homework quiz was set up. So like I'll give you the list of the key points and then a space for you give me the transform point or whatever. Worth pointing out to you, the subskill that's critical to every one of these problems, or virtually every one of these problems, is the ability to pick out the values for A, C, H, and K, right? If you cannot do that, you're going to make a mess out of the describe the transformation. You're going to make a mess out of the amplitude, period, midline frequency problems. You're going to make a mess out of the graphing. Like, you have to be able to do that effectively and consistently, okay? So, like, don't discount that as a skill. Like, you need to be able to do that. Because so many of these problems are just based on finding those numbers and then filling them into formulas, right? Okay. We'll stop here.